Hey YouTube, in this video we're going to look at a couple more examples of partial fraction decompositions. And so let's just go ahead and take a look at this first one on the left here. We have x plus 8 over x squared plus 6x plus 8. So our goal is to rewrite this again as the sum of a bunch of fractions. So we'll start by factoring the denominator. I notice that the factors of this denominator are x plus 2, x plus 4. So we're going to start by rewriting its decomposition. We say, well, with both of these being linear factors here, then we'll get the sum of two fractions having these as their denominators, and also our numerators must be constants. So we'll just use a and b to represent their values up there. So now having this, with partial fraction decomposition, remember that what we're doing is we're multiplying both sides by the least common denominator. And so in this case, our least common denominator is whatever we had as this denominator over here on the left. So if we take everything here on the left times this x plus 2, x plus 4, let's say I do, then that would cancel out with this and we get left with x plus 8. On the right side, if we take everything times x plus 2, x plus 4, we get some cancellations. This is all over 1 we're distributing here. We'd say that my x plus 2 would cancel out with this x plus 2 here, and I get left with a times the x plus 4 part. We say a times the x plus 4 part plus. Now our b, when we multiply b over x plus 4 times this, we get our x plus 4s to cancel out, and we get left with b over x plus 2. So just as we do with partial fraction decompositions, let's go ahead and expand the right side as completely as possible. Ax plus 4a plus bx plus 2b. And then we're going to sort these so that it's in standard form. So we would say ax plus bx. We'll just go alphabetical there. So our x's to the first are in the front. Now we'll put our constants in the back, plus 4a plus 2b. And then we're going to group these. So we say x plus 8 is equal to a plus b of these x things, and then this constant here, the fun thing about it is because it has no variable, we'll just say that all of that right there represents our constant. So now we can say that this 1 right here, this 1 has to be the same thing as a plus b, so our system. Let's go ahead and write out our system here. We say that we've determined that a plus b must be equal to 1 due to the 1-to-1 property, and then this 8 right here has to be equal to 4a plus 2b, so we get 4a plus 2b is 8. So now we get a system here where we get to solve this with substitution or elimination. Let's go ahead and do an elimination. Let's go ahead and multiply this first equation. How about by a negative 2? So if we were to do that, then we would get a new system, negative 2a minus 2b equals negative 2. And then down here we have 4a plus 2b is equal to 8. And our b's now cancel out. We get left with 2a's equaling 6 constants. So a must be 3. And now that we know a is 3, we know that a plus b is 1. So we could go ahead and say that 3 plus b is 1. So this implies that b is equal to negative 2. So I'm going to put boxes around those. But again, what we were trying to do was rewrite this partial fraction decomposition to begin with. So right underneath it, let's do this. Let me get that a little closer. Give myself more room. We're going to write that this is the same thing as a over x plus 2, which our a value we discovered is 3. Plus b over x plus 4, which we discovered our b value here to be negative 2. So this right here is equal to the original expression. Okay. So for this last example, what I wanted to do was a repeated quadratic factor. So when we look at this here, we'd say, well, this is already factored. Our factor is x squared. Our factor is x squared plus 2, and it's repeated. It happens twice. So when we rewrite this decomposition, let's go ahead and start with that. We're going to say that we have to write lesser powers of this quadratic factor if it's repeated. So we say x squared plus 2 to the first plus now x squared plus 2 to the second, and we've got all of its repetitions and its lesser powers. So up on top, the interesting thing here is that because these are quadratic factors, we're going to write linear factors on top. So like ax plus b, cx, we're going to have to introduce a d on this one, d. But now that we have this, again, just like the last one, we're going to multiply everything by the least common denominator, which is this x squared plus 2 squared. And so if we take both sides of the equation times this, again, what's going to happen is that you're going to get these to cancel on the left. We get left with 8x cubed plus 13x. And on the right side, we're going to distribute this. Let's rewrite this. But we get ax plus b, all of that times now this x squared plus 2 is going to cancel out with one of these two x squareds plus 2 and leave behind the other x squared plus 2 to be multiplied by the numerator. So we get that plus, now this times this, those cancel out completely. We just get left with cx plus d. So that's a d right here. And we would end up now looking at something like this after we expand and simplify. Let's go ahead and FOIL here. We will get an ax cubed plus 2ax plus bx squared plus 2b plus cx plus d. And now we're going to arrange these so that it's in standard form on the right side. So we say x cubed, looks like we only have one. We have ax cubed, check. Then we say x squared, looks like we have 1x squared here, so we say bx squared. Now our x's to the first here and here, we would say I have, moving a little faster this time, 2a plus c of these x to the first things. And then our constant here, 2b plus d, we'd say I have 2b plus d of a constant. So now matching these up, the interesting thing here is when we write our system, we have three unknowns. We're going to have several equations here. We'd say x cubed, we'd say a is equal to 8. So a equals 8. Score, we're done with a. We could say, how about this bx squared? Now, because this doesn't have an x squared term over here, it really has 0x squared. What we can conclude is that b then is equal to 0. Also this, we would say this 2a plus c, x to the first, is got to be equal to 13. So 2a plus c is equal to 13. And then last but not least, this 2b plus d equals the constant on the left, but the constant on the left, 2b plus d, is 0. So we get left with this, and I'll tell you what, if b is 0, then plugging that in here, we get left with 2 times 0 plus d equals 0, so d equals 0. So now we have a, b, and d. We just need c, and to find c, we can just plug a in down here. So we get left with 2 times 8 plus c equals 13, or that 16 plus c equals 13. So c has to be -3. So now with all of these values here, a, b, c, and d, what we're going to do is we're going to go back up to this original statement, this guy right here. And we're going to rewrite this as, now, we had x squared plus 2 underneath this one, and x squared plus 2 squared underneath this one. But we had ax plus b, where a is 8. So we had 8x plus b, and b is 0. So we say 8x. And then over here we say x squared plus 2. This is cx plus d, where our c value is -3. So cx is -3x plus d, but d was equal to 0 in this case. So this right here is the completed partial decomposition, fraction decomposition of this right there. And if we were to add these back together, we get back together what we started with. Cheers.